Hello again. Today in ICP we're going to be talking about speed and velocity. Here's our standard that we're going to be covering. Put it more in your guys' terminology. We want to be able to explain relative speed to different reference frames, difference between average and instantaneous speed, and calculate the speed of everyday objects. First thing we're going to talk about here is distance and displacement. Distance is the length of path between 2 points. Displacement is the distance from starting point to ending point. So let's talk about what that really means. Okay, distance. Let's say a guy comes out of a building, travels all the way around the building, comes back to where he started, and essentially he traveled 2 meters there. Let's say he traveled 15 meters there, 15, 15, and then 13. Well, the distance around here then, back to where he started, we would say is 15, 30, 45, plus another 15, is he traveled 60 meters. His distance would be 60 meters. His displacement, however, notice distance from starting point to ending point, his displacement is 0 meters in this case because he's right back to where he started. Okay, the next thing we're going to talk about here is speed. Rate of change in position. Average speed equals total distance over total time. Usually we're going to talk about it in terms of have units of meters over seconds. And the reason that's meters over seconds is because quite often the distance is in meters and usually our time is going to be in seconds. So it's most often is meters per second. Okay, instantaneous speed. That's the speed at any given instant time. And a good example of this is when you're driving down the road, you have your speedometer, and your speedometer says you're going 50 miles per hour, or 55, or 35. That's your instantaneous speed. Your average speed, however, is speed over a longer period of time. And an example of that was you might go to grandma's, and at some point you're driving down the road at 55 miles per hour. You stop, so now you're going 0 miles per hour. Somewhere else down the road, you're maybe on the interstate and you're going 72 miles per hour. Then you're going down a side street and you're going 30 miles per hour. Well, you have lots of different instantaneous speeds, but the average speed of this, alright, the average speed would be, again, taking your total distance over the total time. Now we're going to talk about something different here. It's similar, but we're going to talk about velocity. Velocity is similar to speed, but the difference between velocity and speed is that if you notice here, we've included now direction. So velocity is speed and direction, whereas speed is just how fast you're going. Velocity now, we've got to tell which way you're going. So one example of it might be 55 miles per hour, that's the speed, but now we're going to say east, not east, but east, or you could say south or west. If something's traveling with constant velocity, that means they have no change in speed or direction. Again, no speed, change in speed, and no change in direction. For something to have constant velocity, it has to be still going 55 miles per hour and continue going east. If they were to turn, now the direction's changed, so the velocity would change. Here's our equation. Distance equals velocity times time. We're going to use this, and we can use this equation to solve for the distance, the velocity, and the time. Well, we've got to decode the problem. If traveling down the road with an average speed, so this right here it's saying speed of 20 meters per second. A lot of times we give speed, and even though we're talking about velocity in the equation, so I can put 20 in for velocity. What is the distance? So they're asking what's the distance. That's where it's going to be d if someone can travel in 135 seconds. Well, that seconds there tells me that's the time. Okay, now the question becomes, what's my unit? The distance is 2,700 meters, but what's my units? Well, the velocity was in meters per second. The time was in seconds. Seconds cancel out, and I'm left with an answer of 2,700 meters. Intuitively, you could have looked up here and said, well, the only units for distance that's being used is m up here, which stands for meters. Okay, let's break this problem down. How long will it take for a person to travel 35 kilometers? So that right there, I'm saying that's the distance. If they are traveling 11 kilometers an hour, Whenever they give you a rate, that's your velocity, people, for right now. For right now. So what don't we have then is time. So we take our equation, divide by 11, and we find out that time equals 3.2. Well, how am I going to do this? Well, we took distance, which was kilometers. We divided it by kilometers per hour. Well, division we learned in algebra, we can rewrite this by flip-flopping the fraction. The kilometers cancel out and the thing that's left then is hours. Again, you could look at this intuitively. I've got kilometers, kilometers, and hours. Which one of those units stands for time? Bingo! Hours do. Hey, I'm going to catch you guys on the flip side, but before I let you go, you've got two problems you got to work out. The one where Joe goes to Kentucky, and right here we want to find out the average speed of someone. See you later.